Hello everyone. Welcome to Ohio State University Math 1151 exam prep session. Um, there are a few hours till the midterm, and we are gonna try to prepare you for the midterm by explaining past exam questions. A few notes before we begin. You can see the chat screen on the right. So please use the chat screen and ask your questions immediately. So I will try to answer your questions as soon as possible. And also you can change the um, video quality, and I suggest you to watch it on a desktop, and I suggest you to change it to HD quality. Okay, my name is Eren, and this is the first live exam prep session of masscourse.com, and it's a new initiative, and we will do such exam prep sessions in the future as well. So I begin with the last year's exam questions, and if questions seem too easy for you, please intervene, please direct me, and maybe I can move faster, or if you don't understand anything, please tell me, and I will try to explain that in a more detailed sense. Okay, and also this is an interactive session, so I will ask you questions while you know showing the solution. So please try to answer those questions by using the chat panel. Believe me, you will benefit a lot from that. You will benefit a lot from an interactive session. So the first question, we are given a function graph, and um, by using that graph, we will answer some questions about the function value and about limits. The first question is like determine the value or right does not exist. So the first one, the value of the function when x is equal to minus 3. Can you tell me the value of the function when x is minus 3? Just check the graph and please tell me the value of the function when x is minus 3. So, for example, do we have to do something like, when x is minus 3, I see that, the function value goes to 0, and, we will say 0. Is it something like that? Or are we gonna tell something else? So what do you think? The thing here is, I see a blank dot here, which means that the function value is not represented here, represented at y equals to 0. And I see another dot here, which represents the function value. So please be careful, and the function value when x is minus 3 is represented here, which is the point of y equals to minus 2. Okay, so since this is the function value, I say that f is equal to minus 2 when x is minus 3. And the same thing, f0. When x takes the value of 0 here on this line, I see that the function value takes 1. And I say that f0 is equal to 1. Now, the second question is determine the limit or right does not exist. Right does not exist only if a limit does not exist and is not positive infinity or negative infinity. Please be careful. If the limit goes to positive or negative infinity, you will write that. So please only use does not exist when the limit really does not exist. So the limit, left-handed limit and right-handed limit are not equal. Otherwise, we must write the limit correctly. Okay? So the first question is now limit f function as x approaches to minus 3. So now I will do what I showed you before. When x approaches to minus 3, the function value approaches to 0. As you can see, the function value approaches to here where y equals to 0. Okay, so therefore the left-handed limit, the left-handed limit here and the right-handed limit, they are equal and they are 0. The first one is 0. The second question, limit f(x) as x approaches to 0, but I see a minus sign here, which means left-handed limit. X approaches to 0, but I will focus on the left-hand side. Okay? So x approaches to 0, but left-hand side. So this line is the line where x is 0. So when x approaches to 0 and left-hand side, I will focus on this part and I will follow the line. Where does the line go to? It goes to minus 4. Okay? So the answer is minus 4. Okay, I'll take a brief moment here and ask you whether everything is going okay or not. Please comment, please ask your questions, please use the chat panel. Okay, so the next question is limit f(x) as x approaches to 0. Now think about left-handed and right-handed limits. Okay, so limit x approaches to 0, but left-handed limit x approaches to 0, but right-handed limit. If those are equal, then we have limit f(x) as x approaches to 0. Okay, if those are equal. If those are not equal, what do? We say that limit does not exist. Okay, so we have just found the left-handed limit as minus 4. What about the right-handed? So I follow this line segment here, and I see that the function approaches to 1. Therefore, the left-handed limit is minus 4, but the right-handed limit is 1. So what is the answer? The answer is does not exist. Okay? Because minus 4 is not equal to 1. So limit f(x) as x approaches to 2. As x approaches to 2, this is the line of x equals to 2. I check the left-handed limit and I check the right-handed limit. So I see in both ways, the function goes to, do you have an answer? Both left-handed limit and right-handed limit is equal to, the function goes to, I think it is unbounded. So the function goes to positive infinity. So as you can see, it is the upward side. Therefore, it is going to positive infinity. Okay, so therefore, the limit exists and it is positive infinity. So I repeat, if the limit is positive or negative infinity, you must write that. You will not replace does not exist with a limit which is positive or negative infinity. Okay, so the next one, when x approaches to negative infinity, the limit of fx. So I follow x to negative infinity, and you see y goes to negative infinity as well. And as x goes to positive infinity, I follow y and I see that y approaches to this dashed line, which I call the asymptote and horizontal asymptote, and this line is y equals to 2. Therefore, the limit is 2. Okay, so as you can see, we have found all limits, and if you have any questions, please ask, and I will try to explain in a better way. So still the same function, the same graph. Now we have a multiple choice question. We will choose only one answer. Find a number a for which the following statement is true. The function f is shown above. Statement: the function f is continuous at a and limit fx as x approaches to a is 0. So what am I gonna do? Let me think about the definition of continuity. So if a function is continuous at a, I have limit fx as x approaches to a equals to fa, the function value at a. So therefore, these two must be equal if the function is continuous at a. So therefore, I will find a point of x where the function value equals to 0. Okay, so the function value equals to 0. So y will be equal to 0. Where is the line of y equals to 0? This is the x-axis. Along the x-axis, y is equal to 0. So I follow this one. Oh, there's a point here, and we will talk about that. And I follow again, and there's a second point here. So which one? Is it x equals to 3? And is it x equals to minus 3? You see, when x is minus 3, the function value is not equal to the limit. The function value is here, which is minus 2, and the limit is here, which is 0. Therefore, the function value is not equal to the limit, and the function is not continuous at x is equal to minus 3. But here, it is the pure graph of continuity. You have the limit, which is equal to the function value here, and it is 0. So here, the limit equals to the function value, and that is equal to 0. So we have a equals to 3 because when x approaches to 3, the limit equals to the function value, which is 0. Okay? So this is the answer. And part D, determine the largest intervals of continuity of f. Use interval notation to write your answer. So we are going to find the largest intervals of continuity of f. So I will copy and paste the graph, and I will try to find the largest intervals of continuity. And I will find line segments which are continuous, which are not interrupted. For example, here, this is the first line segment. So this is x going from minus negative infinity to minus 3. Okay, so the first one, negative infinity till 3, and I will have a rounded bracket here because it is minus 3, sorry. I will have a rounded bracket here because we will not include minus 3 because the function is not continuous at minus 3. The second continuous line segment is from minus 3 till 0. So this is the second continuous line segment. So could you please tell me the third one? What is the third interval at which the function is continuous? Please write on the chat panel. Great. So the third one is 0, 2. Okay, very good. So we have two answers. Our friend Karan said 0 is not included, and another answer, 0 is included. Which one? So the question is, if the function is continuous at 0, then 0 is included. If the function is not continuous at 0, then it's not. So I check where the function when x is 0. So as you can see, right-handed limit, left-handed limit, they are not equal. So the function value is here, but the left-handed limit is here. Of course, the function is not continuous at 0. Therefore, rounded brackets, 0 is not included. And of course, the fourth one is 2 positive infinity. Okay? So, part E. Write the equations of all vertical asymptotes. Write none if appropriate. What's a vertical asymptote? As you know, a vertical asymptote is like the function approaches to this y value, but never, excuse me, the function approaches to that x value, but never takes that x value. So it is like x values which are undefined. Okay? So what do we have here? We have only one vertical asymptote, which is x equals to 2. And write the equation or equations of all horizontal asymptotes. Okay, can you write me an answer about the horizontal asymptote? So, can you see a horizontal dashed line? So the function will approach to that dashed line, but yes, y equals to -2 is exactly a horizontal asymptote. Okay, so this question is completed, and please write me if you have any questions, any points that you need clarification for the previous question. So now, question 2. We have three functions g, f, and h defined on the interval -2, 2. It's an open interval. Given that gx equals to cos px, hx equals to absolute value of x plus 1, and gx is smaller than or equal to fx, and fx is smaller than or equal to hx. Answer the questions below. Sketch and label the graph of gx, g, and h, and a possible graph of f in the figure below. So we will sketch g and h functions, then we will just try to find a sketch for f. So the first one, gx, we have cos px here. I just think the important points for the cosine function. For example, I know cosine 0 equals to 1. For cosine 0, we must have x equals to 0. So when x is 0, I have the g function being equal to 1. This is the first point. The second one, cosine p over 2. So cosine p over 2 equals to 0. What is the x value which takes me to cosine p over 2? That is 1 over 2. Because now g function is like cosine px. So when x is 1 over 2, I have cosine p over 2. So therefore, when x is 1 over 2, the function value is 0. We have the next one, cosine p. What's cosine p? Cosine p is minus 1, right? So, which appears when x is equal to 1, because we have cosine px. When x is equal to 1, we have cosine p. So therefore, the next point is x is 1 and y is minus 1. So we have cosine 3p over 2, which is when x is 3 over 2. Okay, so what's the value of cosine 3p over 2? This is the same as cosine minus p over 2, and which is 0. This is the next point. And the last one is cosine 2p, which is 1, which we have when x is 2. Okay, so I will draw a cosine function like this. This is the first one. And please check the other points, like x is minus 1 over 2, and then x is minus 1, and then x is minus 3 over 2, and x is minus 2. Okay, so this is the graph of gx. And the second one, hx, which is absolute value of x plus 1. First, I will sketch the absolute value function. So absolute value of x. Absolute value of x equals to x when x is greater than or equal to 0, as you know. And the absolute value of x equals to minus x when x is smaller than 0. So I sketch y equals to x. This is just this line when x is greater than or equal to 0. And I sketch y equals to minus x when x is smaller than 0. But as you can see, now I've just sketched the absolute value of x. But h function is an absolute value of x plus 1. So I must shift this function 1 unit upwards. Okay? So therefore, the sketch is like this. So I erase the previous sketch. So I have hx here. And let's find a possible graph for f, which must be in between, because f is smaller than or equal to hx and greater than or equal to gx. So in between. I have plenty of space here, but it gets narrower as x approaches to 0, because gx and hx, they are both equal to 0 when x is equal to 0. So therefore, f must pass through the point 0, 0. Okay? So it gets wider again. So this is a possible sketch for fx. So this was the sketching part, and part B, use the sequence theorem to evaluate the limit fx as x approaches to 0. Okay? So what does sequence theorem say? If, let's say, Let's write it as it is here. Gx smaller than or equal to fx, and it is smaller than equal to hx for every x, and limit gx as x approaches to a equals to limit hx as x approaches to a, then limit fx as x approaches to a must be same to these limits. Okay? So, the reason is very simple, because f must lie in between, and if they have the same limit, then f's limit must be same as well. It is like the thing we have seen in the graph. Okay, so when g and h has the same value, f must take the same value as well. So we know that limit gx as x approaches to 0 equals to limit hx as x approaches to 0, and that limit is 0 as well. So therefore fx has the same limit as x approaches to 0. Okay, the idea of the sequence theorem is so simple. And in part C, we have to find the limit of gx over x squared minus 5x as x approaches to 0 and right-handed limit. So the limit is limit cos px over x squared minus 5x. So when you have to find the limit, first you just replace the x value in the functional form. Okay, so let's check cos p times 0 over 0 squared minus 5 times 0. So denominator, cosine 0. Cosine 0 is 1. And the denominator, 0 squared minus 5 times 0, which is 0. So I know that it's going to be infinity, but I'm not sure if it is positive infinity or negative infinity. How am I gonna find it? So let's think about cosine p0, which means cosine 0, and let's think about x squared minus 5x. So I just need to find whether they are positive or negative. First, cosine 0. What is cosine 0 as x approaches to 0, but it is right-handed. So x is very small but positive now. X is very small but positive now. It is, of course, 1. It's a positive value. Okay? The denominator is positive. Now the second one. X squared minus 5x. Limit x squared minus 5x. You know, x approaches to 0, but right-handed limit. So let me write it like x times x minus 5. So I have factorized x squared minus 5x. So this one here is positive because we have 0, but we have the right-handed limit. So it is a very small number, very small number, but it is still positive. Okay, do you understand that? It is still positive. So that's why x is positive. So what about x minus 5? I think it is so clear. When x is around 0, x minus 5 for sure negative. Therefore, this thing here is negative as well, because positive times negative is negative. So now I have a positive term in the numerator and I have a negative term in the denominator. Therefore, What's the answer? Positive over negative. What do you say? So I have 1 over 0, but I've investigated the signs. I found that the numerator is positive, but the denominator is negative. And hence, we have negative infinity as the limit. Okay? Do you understand that? So, this is a very important part when the limit is infinite, when it is like, a over 0, okay? You must check the signs. So, by checking the signs, you will find whether the limit is positive infinity or negative infinity. Is that clear? Is that clear? If that's okay, I'm gonna go through the next question, okay? But please provide your feedback for the previous part. So the next question. Let f be a function defined by fx equals to 12 over x plus 2. Write the form of the limit and evaluate the limit. Do not use L'Hopital's rule. Show your work. So we will not use L'Hopital's rule. So therefore, we will write this expression clearly. So first, let's find the function value when x equals to 1. That is 12 over 1 plus 2, which is 4. Okay? Now I have limit as x approaches to 1. I have 12 over x plus 2, because that was fx, minus 4 over x minus 1. So the only thing I will do is writing the denominator and more clearly. So by multiplying 4 by x plus 2, I have 12 minus 4x minus 8 over x plus 2 and over x minus 1. And I have 4 minus 4x over x plus 2 times x minus 1. And that is 4 minus 4 times x minus 1 over x plus 2 times x minus 1. And these cancel out. And we have minus 4 over x plus 2, which gives us minus 4 over 1 over 2, and which is minus 4 over 3. Okay? So the only idea here is like when we write the expression in a clearer form, we were able to cancel x minus 1s out. So then just replace the relevant x value and you will find the limit. That's it. B. Find the natural domain of f. Write your answer in interval notation. Okay? So you see the f function and I'm going to just wait for your answer. Please reply and just tell me the natural domain of f. So what is the largest possible domain of f function? Okay, just tell me that. What's the largest possible domain of f function? Okay, please write your answers. Thanks for the answer. So we have like minus infinity to 2 and united by something like 2 to positive infinity. And this equals to the real number set minus just 2. Why we take 2 out? Because as you can see, excuse me, it is not 2, it's minus 2. It's minus 2. Because, you know, in the function, we have the denominator equals to 0 when x is minus 2. So let's correct these 2's as minus 2. So we exclude minus 2 from the domain because minus 2 when x is minus 2, the denominator is 0 and the function becomes undefined. So let f inverse be an inverse of f. Find an expression for f inverse x for x in the domain of f inverse. So let me write the expression of the f function 12 over x plus 2. What I do here is like y equals to 12 over x plus 2, and then I just try to write this like x is equal to some expression in terms of y. So to do that, I just switch these things like x plus 2 equals to 12 over y, and x is equal to 12 over y minus 2, and finally x is 12 minus 2y over y, which leads to the answer f inverse x equals to 12 minus 2x over x. Okay? So, as you can see, we have found an expression for f inverse x. Part D. Find the value or say does not exist. So, the first one, f inverse f of p. What do you say? So, what do you do? What is your suggestion? F inverse f p. So first, you know, this is like the f function. Let's check where it leads to when it takes p as input. Then this is f of p, and then we will send that f of p to f inverse. Okay, so the question here is, do we need to calculate the values? For example, first, you know, let's take this f of x expression and let's take f inverse expression. Okay, the question is, do we need to calculate these values? Let's check it. F of p, 12 over p plus 1. Okay, so this is fp value, and f inverse 12 over p plus 2, which is 12 minus 2 times 12 over p plus 2, okay, and over 12 over p plus 2. I rearrange, and what I find is 12p plus 24 minus 24, okay, over 12, because p plus 2's cancel out, which is 12p over 12, and which is p. Is that surprising? Exactly no, because f inverse and f, they do just the opposite. They just cancel each other out. It's like, let me give you an example. It's like, inverse functions. It's like the ln of e to the power x. These two functions are inverses of each other. So that is x exactly. For example, e to the power, okay, ln x squared plus 5. They are inverse functions. They cancel each other, and the answer is x squared plus 5. And what about the second part? We have f of f inverse 0. What is your answer? And please remember what we have done in the previous part, okay? What do you say? F of f inverse 0. Or let me ask you, like, do you think the answer is 0? Do you think we can say that, okay, it is like f and f inverse, they cancel out, and let's say 0? Do you think that? Okay, the thing is, yes, they cancel out, but here we have f inverse 0. When we check the f inverse function, we have 12 minus 2x over x. So f inverse is not defined when x is 0. Therefore, this functional value does not exist. It is like saying e to the power ln minus 1. Okay? The exponential function and logarithmic function cancels each other. That's fine. But logarithmic function is not defined for negative values. So therefore, we don't say minus 5 as an answer to this question. We say does not exist. Okay? So since the inverse function is not defined as x equals to 0, then the answer here is does not exist. Okay? So um, this was the last question for today's exam prep session, but um, you are very welcome to ask anything you like. Otherwise, I'm gonna end the session here. Okay, thank you for watching our live session, and we want to do that again for the second and third midterms. And please um, give your feedbacks um, about the session or about the Math 1151 course. And again, I thank you for watching the session, and you can watch the recorded version via the same link after the session ends. Thank you and success in the exam.